Good afternoon, everyone. I am Mr. Ish. Thank you for joining me. We are looking here at a single but challenging differential equation, one that we need to solve. We have y tan x divided by a square minus y square dy over dx is equal to 1. For the condition pi over 4 placed into the original function will give an output value of 0. F of pi over 4 equals 0. How do you go about solving this? When you're looking at that, it looks something like a separation of variables form of equation where you can easily separate the y and the x without any problems, and that's exactly the route you want to take. Look, you'll have y over a square minus y square dy over dx is equal to, you take the tan x onto the other side, you'll have 1 over tan x, but you know 1 over tan x, the reciprocal is cotan x. That's exactly what you have. Now, when you have separated the variables, you bring in the integral sign, you'll have a dx here and a dx here. This cancels out with this. So what do you end up seeing? You end up seeing y over a square minus y square dy is equal to the integral of cotan x dx. And now you take this forward into completion, and it's challenging because of the parts that come later on, and you will see that to be the case. You know you're looking here at trigonometric substitution, not too hard, we can do that. If supposedly a prime were equal to a, then you're looking here at y is equal to a sine theta, because we're looking here at the form a square minus x square type of trigonometric substitution, for which you bring in the sine and the cosine items. When y is equal to a sine theta, then dy is equal to a cosine theta d theta. And you'll bring that into play right here. And nothing over here is out of the norm, except you're looking here at things with regards to y. Y is equal to a sine theta, dy is equal to a cosine theta d theta, and then right here you'll have a square minus y square, which is a square sine square theta. All of this is equal to the integral of cotan x, but why don't we just skip this step and just bring in the antiderivative, natural log sine x plus c, and that right there is your antiderivative of this. When you clean this up, you know you're looking here at an a square from the numerator, you have a sine theta cosine theta d theta. Here you'd isolate an a square, and then you'll have 1 minus sine square theta. But this 1 minus sine square theta, by means of the Pythagorean identity, is equal to cosine square theta. And you can bring that into play right here. So we have a square cosine square theta. These cancel out. This cosine theta will cancel out with one of the squares of this. In essence, you're just looking at the integral of sine theta over cosine theta d theta, which you know is just tan theta d theta. That's exactly what you have. You have a tangent function with regards to theta and its integral that needs to be determined, which you know is natural log secant theta. Don't bring the constant of integration, because this is coming here from the y variable. So this is equal to this. As you know, the separation of variables, their individual integrals being handled, this coming from the left hand side, this coming from the right hand side. Now we have to make sense of this theta and get rid of it by looking right over here, and we will do so. If you solve for this theta, theta is equal to arc sine y over a. That's exactly what it is, arc sine y over a. Construct a triangle which brings in the theta variable with regards to the definition of sine, which is y over a, opposite over hypotenuse, and then you have a square minus y square, and that's exactly what you have. Now you have to bring all of this in with respect to secant. You're really looking at a natural log secant of theta, which is really, as you know, arc sine y over a. When you're bringing in the secant with regards to that theta function, what's secant with regards to theta? You're looking at hypotenuse over adjacent, and this is exactly what you have. This comes in terms of exactly what you see over here. All of this will come right over here, because I've solved it out by eliminating the secant theta variable and bringing in everything else which it represents. It represents everything out of that triangle by means of this item over here. So we know now this right here is equal to this right over here. So let's do something with that. What we'll do is we'll come down over here and we will erase this part, bring everything here into a clean format. I'm going to do a substitution over here which you're familiar with. Natural log a is equal to c, because I want to get rid of the constant of integration and bring in natural log. So I know now c is equal to natural log a, which is combining with all of this over here. This is everything from the left hand side, this is everything from the right hand side. So let's do it. Natural log a divided by a square minus y square within a root is equal to this. Bring it into a common log by means of properties of logs. Individual logs in a sum format are equal to under a common log in a product format. Natural log a sine x. Properties of logs will help eliminate the natural log. So you really have a over all of this. Root is equal to a sine x. So let's take this to completion here. It will eliminate this because you don't need to see this anymore. You know this. This right here is just pre-calculus stuff. What we can do is bring in this. This is x. This right here is y. But what exactly is y over here is exactly what you see. What is exactly x? The x variable you have over here. This a over here, as you saw in this original part of your question, represented a constant or a numerical value. And then this a is coming out of the constant of integration. This 0 will plug here in terms of y. So you'll have a over square root of a square minus 0 square is equal to, these natural logs have dissipated, they're gone away, is equal to a sine of pi over 4. And that's what you have coming from right here. Well, we know what sine of pi over 4 is. It's 1 over root 2. It's a over root 2 is equal to a over root of a square. Root of a square is really equal to an a. And you know that a over root a square is equal to a over a, which is equal to 1. This all simplifies to 1 and you'll verify that yourself. A is equal to root 2. That's what I'm getting here. So what do I do with this root 2? It comes right in over here into this expression, and then we clean it out and present the final answer. We have a over root a square minus y square is equal to root 2 sine x. But this can be your answer if you want, and you can stop right there. I want to present this in a good way. If I were to eliminate these radicals, I can by hitting everything with squares. You see, I'll hit everything with squares. I'll have a square over a square minus y square is equal to 2 sine square x. This again can represent an answer as well. This can be one of your answers. A square divided by a square minus y square is equal to 2 sine square x. Or we can present the answer in another way, and I can do so exactly right over here. I'll erase this part right here because we've done this part. You don't need to see it. You can always rewind and see it. Look how I'll present everything. I'll take the 2 down here. I'll take the a square minus y square on the other side. So I essentially have a square over 2 is equal to a square minus y square in a parentheses form times sine square x. And this can again represent a good answer. So there are multiple good answers. You could have not squared everything and keep everything as this, or you can keep everything as this, or you can do this. These are all good answers. I think I'll just stop right here. But that right there will represent the function or the equation for which this differential equation is true. Y tan x or a square minus y square dy or dx equals 1, with the condition that f of pi over 4 is equal to 0, and the fact that we substituted the constant of integration with natural log a because it helped eliminate the natural logs across. And the answer is provided for you right over there. And that'll be it for this particular video. Hopefully you enjoyed it. Thank you for watching. Have a good day.